Hi Rangers, today we're going to be going over limits again. So our objectives for this video is to make the connection between limits to infinity and horizontal asymptotes. So what I want you to do is write down the following statement. Limits to infinity are the same as horizontal asymptotes. Again, limits to infinity are the same as horizontal asymptotes. So, some tricks that we have to help us with limits to infinity. When we're dealing with rational functions, if the degree of the numerator is less than the degree of the denominator, the limit is 0. Okay, so I have a little acronym to help us. BOBO, bigger on bottom. So an example of what this would look like is if I had x plus 3 over x squared plus 2. Okay, my degree is bigger on bottom because it's a degree of 2 versus on top it's a degree of 1. If the degree of the numerator is greater than the degree of the denominator, the limit does not exist. Okay, this is bottom. Bigger on top, none, or does not exist. Okay, so an example of what this would look like would be if we flipped that fraction. So if I had x squared plus 2 on top and x plus 3 on bottom. Now my degree is bigger on top. If the degrees of the numerators equal the degrees of the denominator, for the limit, what we're going to do is we're going to take a ratio of the leading coefficients. Oops. Okay, so what this would look like would be if I had 1x squared minus 4x over 2x squared minus 3. Okay, notice both my degree in the numerator and denominator are 2. So I'm going to take a ratio of their leading coefficients, which is 1 and 2. So it would be 1/2. Okay, now number 2 is going to help us when we're dealing with non-rational polynomial functions. So the order from smallest to biggest would be the smallest is logarithmic functions, then it goes polynomial functions, exponential, and the biggest function would be a factorial. Okay, so our first examples. Consider the graph of the functions f. The dashed lines represent the asymptotes. Okay, so we want to know what is the limit as x approaches negative infinity of f of x. As x approaches negative infinity, okay, so as we approach negative infinity, right here, okay, it looks like our graph is approaching that asymptote of -5. Okay, as x approaches positive infinity, it looks like we're approaching that asymptote of 3. So we have to make sure that we evaluate the limits as x approaches positive and negative infinity. Okay, if we only looked at negative infinity, then we would have missed that 3 as an asymptote. If we only looked at positive infinity, we would have missed -5 as an asymptote. So you always have to make sure when you're looking for asymptotes, we look from the left and the right side of the limit. Okay, so positive and negative infinity. Number 2, which graphs agree with this statement? Select all that apply. So the limit as x approaches infinity of g of x is equal to -2. So as we approach positive infinity, the limit's going to approach -2. So as we approach, so let's look at answer choice A. As I approach positive infinity right here, it is approaching -2. So we are going to select that one. If I look at answer choice B, as I approach positive infinity, this is also approaching -2. And last but not least, answer choice C, as I approach negative or positive infinity, this one is approaching -1, so it does not work. Moving on to the next page. Okay, we want to find the limit and we want to identify the asymptotes. Okay, so remember our asymptotes have to be written as an equation because they're horizontal. That equation is going to be y equals a number. Okay, so looking at number 3, if I'm just looking at it and I'm thinking Bobo, which is bigger on bottom, Botan, bigger on top, or eats to see is where we take the ratio because the degrees are the same. Okay, I look and I see that my degree is bigger on bottom. When it's bigger on bottom, the limit is going to be equal to 0, and the asymptote is going to be equal to 0 as well, so y equals 0. Okay, so again, I pulled this information from up here. I did forget the last one, which I did say, but it's eats DC. Okay, so these are the acronyms that I'm referring to when I'm looking at this. Looking at number 4, okay, I look at my degree of the numerator, it's 5. I look at my degree of the denominator, it's 2, which means the limit does not exist because it is bigger on top. And when it's bigger on top, the limit does not exist. And for the asymptote, there is not one. So there's none. Okay, looking at number 5, the limit as n approaches infinity of 4n squared divided by n squared plus n. Okay, if I look, I notice that my degree in the numerator is 2. My degree in the denominator is also 2. So my exponents are the same. We're going to divide the coefficients, eats DC. So I'm going to take 4 and 1, and 4 divided by 1 is 4. So my limit is approaching 4, which makes my horizontal asymptote y equals 4. Okay, looking at number 6, again, when you see the asterisk like this, that means this was a previous AP question. So let's look at it. If the graph of y equals ax plus b divided by x plus c has a horizontal asymptote of 2 and a vertical asymptote of -3, then what is a plus c? Okay, so how we can figure this out is first, let's talk about the asymptote. Okay, we know that the asymptote is 2. So if we're thinking about it, it can't be bigger on bottom because that would be a 0 asymptote. It can't be bigger on top because that would be does not exist asymptote. So that means it has to be eats to c, where that my exponents are the same on top and bottom. And I have to divide the leading coefficients. Well, the leading coefficient for the denominator is 1. So I need to figure out a divided by 1 has to equal 2 because my horizontal asymptote is 2. Well, to solve, it tells us right there that a has to be equal to 2. Now, for the vertical asymptote, if we want it to equal -3, that means I have to take my denominator and I have to set it equal to 3. So -3 plus c is equal to 0. Okay, how did I know that? All I did is I replaced that x with this -3. And to solve, I add 3 to both sides. which tells me C equals 3. So to answer the question, what is A plus C? A plus C would be 5. Okay, looking at the next question. Okay, another AP test question. It says for x is greater than or equal to 0, the horizontal line y equals 2 is an asymptote for the graph of the function f. Which of the following statements below must be true? So if we think back to what I said or told you to write down at the beginning of class, limits to infinity are the same as horizontal asymptotes. Okay, it tells us that our horizontal asymptote is at y equals 2. And if I look at answer choice E, it has the limit as x approaches infinity of f of x equals 2, which is a limit that's going to infinity, which means it's another way to write a horizontal asymptote. Okay, so moving on to the next one, question number 8. So we're just going to practice taking the limit some more. Okay, so the limit as n approaches infinity of 7n to the 4th plus 500 divided by 3 to the nth power. Okay, so we have an exponential function on top, and we have a polynomial on top, exponential on bottom, sorry, correction. And if we look back at our first page of the notes, exponential is bigger than a polynomial. So that means that I am bigger on bottom. And my limit is going to go to 0. Okay, looking at the next one. I have a logarithmic function in the numerator and a polynomial function in the denominator. Again, if we go back up, okay, logarithmic function is smaller than a polynomial function, okay, which means that I am bigger on bottom again. And when it's bigger on bottom, the limit is 0. Looking at number 10, okay, I have 2x to the 4th on top, and then what I have to remember to do is I'm going to take the square root of 4x to the 8th, and I get 2x to the 4th. Although I'm not really taking the square root, that's just our quick way of doing it. I notice that my exponents are the same. So when the exponents are the same, we divide the coefficients. So to divide the coefficients, I'm going to take 2 divided by 2, and I get 1. Number 11, same concept as number 10. Okay, this would give me 2x to the 3rd. So I have degrees that are the same. So exponents are the same. Divide coefficients. So I'm going to divide 5 over 2, and it doesn't simplify, so I just leave it as 5 halves. Okay, so I want you to pause the video and try these 4 on your own to see if we really understand. Okay, so hopefully you paused the video and you gave them a chance. So let's see how you did. So number 1 would be, again, the eats DC because I have exponents that are the same. So I divide the coefficients and I get a negative 1/4. Looking at number 2, my degree is bigger on bottom. 4 is bigger than 2, so therefore my limit would be 0. Number 3, my degree is bigger on top. 4 is bigger than 3, which means my limit does not exist. Number 4, I'm going to take the square root of 9x to the 4th. I get 3x squared. Therefore, my degrees are the same. So I take a ratio of the leading coefficients, which is 6 over 3, and that gives me 2. Okay, on number 5, again, same concept. Square root of 9x to the 6th would give me 3x to the 3rd. My degrees are the same, so therefore I take a ratio of the leading coefficients, and that gives me 3 over 1, which is just 3. So if you have any questions, make sure you write them down and you ask me when you get a chance.